The SR-71 Blackbird remains one of the most awe-inspiring feats of engineering in aviation history. Even decades after its final mission, its legacy looms large, symbolizing the relentless pursuit of innovation during one of humanity's most tense and uncertain eras. Designed in utmost secrecy and flown with unmatched precision, the SR-71 achieved what most thought was impossible, solidifying its legendary status. But what are the secrets that made it so unique? Let's uncover the fascinating story behind this extraordinary aircraft. The journey begins in the late 1950s. The Cold War between the United States and the Soviet Union was at its height, and intelligence gathering had become a key element in maintaining global stability, or at least avoiding outright catastrophe. The U-2 spy plane, introduced earlier in the decade, was revolutionary for its time. It flew high enough to evade early fighter jets and missiles while gathering crucial reconnaissance imagery. However, the downing of a U-2 over the Soviet Union in 1960 exposed its vulnerability to more advanced missile systems. This event forced the U.S. to rethink its approach to reconnaissance and pushed engineers to create something faster, higher flying, and far more elusive. This pressing need brought Lockheed's Secretive Skunk Works into the picture. Led by the legendary aerospace engineer Clarence Kelly Johnson, Johnson and his team set to work, under a cloud of secrecy, to design an aircraft capable of redefining the limits of speed, altitude, and stealth. Their answer? The A-12, the immediate predecessor to the SR-71. The A-12 laid the foundation for an entirely new class of reconnaissance aircraft. Still, its successor, the SR-71, would refine and perfect the design, delivering unmatched capabilities that would endure for decades. From the outset, the SR-71 was designed as a near-impossible challenge. Imagine designing an aircraft capable of cruising over 3 times the speed of sound, faster than a bullet, while soaring above 85,000 feet. At such speeds and altitudes, conventional materials couldn't withstand the immense heat and pressure. This led Johnson and his team to a groundbreaking solution, constructing the plane primarily from titanium, a metal known for its strength and ability to endure high temperatures. However, working with titanium came with its own set of challenges. The metal was notoriously difficult to machine and manufacture, requiring entirely new techniques to build the SR-71. To add to the complexity, much of the world's titanium supply was in Soviet hands, forcing the U.S. to acquire it covertly through third parties. This single example highlights the extraordinary lengths to which the team went to ensure this project's success. Beyond its materials, the SR-71's design itself was revolutionary. Its sleek, angular shape wasn't just for aesthetics. It was a deliberate attempt to minimize radar cross-section. Though not fully stealthy by today's standards, the SR-71's profile made it remarkably difficult to track compared to other aircraft of its time. The incorporation of chine lines along the fuselage and wings further enhanced its radar-deflecting capabilities, pushing the boundaries of what was thought possible in stealth technology. Of course, it wasn't just about being difficult to detect, it was about outrunning any threat. The SR-71's Pratt and Whitney J58 engines were marvels of engineering in their own right. These engines operated in turbojet mode for low-speed performance, but transitioned into a ramjet mode at high speeds, making the SR-71 one of the fastest aircraft ever built. It cruised comfortably at Mach 3.2 and could surge even faster in short bursts. In fact, during its lifetime, the Blackbird shattered speed records that still stand today. For perspective, at Mach 3.2, the SR-71 could cross the continental United States in just over an hour. Enjoying the secrets behind the SR-71 Blackbird? Don't forget to hit that subscribe button and turn on notifications to dive deeper into more fascinating stories like this one. Such incredible speed had practical applications beyond bragging rights. The Blackbird's top defense against surface-to-air missiles or interceptors wasn't countermeasures, it was simply acceleration. If a missile locked onto the SR-71, pilots had one simple instruction: throttle up. The Blackbird was so fast that no missile ever successfully hit it during its years of operation, despite over 4,000 attempts. Yet, speed and altitude alone weren't enough to secure its reputation. The SR-71 was designed as an intelligence gathering tool, capable of delivering detailed reconnaissance from its missions. The plane carried state-of-the-art sensors, cameras, and electronic intelligence equipment that could map terrain, monitor enemy activity, and capture high-resolution imagery, all while flying far above the range of anti-aircraft systems. In many ways, it served as a precursor to modern surveillance satellites, offering unparalleled intelligence capabilities. Operating such an advanced machine was no easy feat. SR-71 pilots, affectionately known as sled drivers, were some of the most skilled and well-trained aviators in the world. Flying to altitudes where the atmosphere was barely thick enough to sustain flight required precision and nerves of steel. Pilots wore specialized pressure suits, akin to those used by astronauts, to protect them from the thin air and extreme conditions of high-altitude flight. These suits were not just protective, but a necessity. At 85,000 feet, even a minor cockpit failure could lead to catastrophic consequences without them. The SR-71's missions were carefully planned and executed, often requiring mid-air refueling to extend its range. A typical mission would see the Blackbird refueled immediately after takeoff to ensure it could operate at full capacity. Refueling at such high speeds and altitudes added another layer of complexity, showcasing the exceptional skill of both the pilots and their support crews. One of the most intriguing aspects of the SR-71 was its fuel system. The plane used JP-7, a special high-temperature fuel developed specifically for the Blackbird. JP-7 was so stable that it wouldn't ignite easily, requiring a chemical ignitor, trithoborane, TDB, to start the engines. This characteristic also served as a safety feature, as JP-7 was less prone to vaporize or ignite during high-speed flight. But the use of JP-7 also highlighted one of the Blackbird's most infamous quirks. On the ground, the SR-71 was notorious for leaking fuel. Its titanium skin panels were designed to fit loosely at ground temperatures, allowing them to expand and seal tightly during high-speed, high-temperature flight. This meant that before it took to the skies, the Blackbird appeared to be leaking fuel all over the tarmac, an ironic characteristic for one of the world's most advanced aircraft. The Blackbird's operations were shrouded in secrecy for much of its life. Even after it was declassified, much of its mission data and operational history remained hidden. But what's clear is that the SR-71 played a critical role in U.S. intelligence gathering, particularly during the Cold War. From the Cuban Missile Crisis to surveillance missions over North Korea and the Middle East, the Blackbird proved time and again that it was an indispensable tool in maintaining global stability. Despite its remarkable achievements, the SR-71 was retired in 1998. By this time, advancements in satellite technology and the high operational costs of the Blackbird made it less practical for modern reconnaissance missions. However, its influence continues to be felt in aerospace engineering and aviation. The SR-71 inspired future generations of aircraft and engineers, pushing the boundaries of what was thought possible in both military and civilian aviation. Today, the remaining Blackbirds rest in museums, where visitors can marvel at their sleek lines and imagine what it must have been like to fly one of these incredible machines. But beyond its striking appearance and record-breaking speed, the SR-71's legacy lies in its embodiment of human ingenuity and determination. It represents an era when engineers and pilots alike dared to dream bigger, push harder, and defy the limits of what was possible. In the end, the SR-71 Blackbird was more than just an aircraft. It was, and still is, a testament to what can be achieved when innovation and ambition meet. Its secrets, once closely guarded, now serve as inspiration for future explorers and innovators, reminding us that the sky is not the limit but just the beginning. Thanks for watching. Make sure to like, comment, and subscribe for more legendary stories and groundbreaking innovations.